is a pretty good one to start off with because it has evidence of everything I've been talking about. First of all, we've got to look at the layers of rock and what their names are, because that tells us an awful lot about what happened to make them. And the names for these rocks are over here. First of all, I've named the layers so I get an idea of what's actually there. So all of these layers along here that are all quite horizontal in the way that they are leveled, these are all sedimentary rocks. Limestone, shale, sandstone, limestone, shale. So these sedimentary rocks tell me that these were made by sediments being deposited down because of the environment around them. Now remember, sediments get deposited down by wind or by water, and each one of these has its own story, as we learnt in the sedimentary rock video. Before we look at that, let's also have a look here. We've got igneous rocks here, here, and here. Now, this one is actually pushing up through the layers. So I'd say that this one here is younger than all these layers around it. This one here is also pushing up through the layers, so it's going to be younger than the ones around it. Now this one here, if you look around here, these layers don't show any evidence that this has pushed up through them, because if this large piece of rock, or in that case molten lava, was pushing up from beneath, you think about it, the layers around it would actually be bent around as it pushes up through them. You can see that these layers here don't show any evidence of being disturbed. They've actually been layered over the top of this original rock here, because they don't show any evidence of being disturbed by it. So this has come before these layers. Now let's have a look at these sedimentary rocks here and tell their story. Limestone is formed when dissolved shells and skeletal remains of marine organisms is redeposited and recrystallized as rock as the water around it evaporates. So that tells me at some point here, this area here was covered in water, and that water evaporated, leaving limestone behind. There's the first part of my story. Now on top of that is shale. Now shale is mudstone. So that means that this area had to have mud deposited over it. Now think about what happens for an area to be covered in mud. Again, usually mud comes not with wind but with water. So this area was again covered in water and mud layered over the top of it. Then we have sandstone. Now sand can be deposited again by water or by wind. We don't know which here, but the sandstone has actually been deposited over the top of the mud. One way to tell whether this was wind or water is we look for evidence of little fossils here. If you see little fossils like shells and stuff in this sandstone, then you can assume that the sand was actually deposited by water, and that this used to be, again, covered in water, and as that water was in there, a lot of sand was deposited, and then that water has gone away. After that, we have another layer of shale being laid down. Now again, mud was layered down. Now notice here we have now a very distinct line here which goes across and down here, and it doesn't line quite up because it lines up with, look at this, a cross-cutting or a fault. Okay, so this whole layer here slipped down, and it used to be up here, but it's actually slipped because of the fault. So we have had a fault occur, but it's happened after all these layers got laid down. Now this distinct line here, where the shale has just been almost rubbed away, that distinct line shows erosion. So some of the rock has actually been eroded back down, and you're left with a very distinct line that we see like this. Then we've had sandstone deposited on top of it again. So again, either wind or water has deposited sand on top of this shale. Now, did that sand get put down before or after the fault that I just had here? Well, let's have a look at the evidence. If the sandstone was put down before this cut or this fault occurred, it would show signs of slipping down as well. Now, does it? No, it doesn't. It actually fills in the gap that was left behind after it slipped. So this shows me that this sandstone is actually younger than that cut right there. Okay, now the next layer we have is limestone. Again, limestone, marine organisms, water's evaporated away, the dissolved shells then re-solidify and you get limestone. So we've had another layering event with water. And then we have this shape here with this igneous rock. Look at this. And look at what you see above it. Okay. Now, as you can see here, this shale here seems to be pushed up by this igneous rock. The question is how and why. Now, as we can see, this igneous rock has pushed its way up through these layers. Because it's still in a nice thin tube and it's not spreading out, we can assume that up until this point it was the youngest piece of rock pushing through other pieces of rock. But here it's spread out and pushed this stuff above it. Now I'm assuming here that this has actually hit the top of the rock and come out underneath what the shale used to be. What did shale used to be? Shale used to be mud. So you think about it, if igneous rock hits the surface and it's coming out underneath mud, it's not always going to push right through the mud, it's going to push the mud up, and this one has solidified underneath the mud. So we have igneous rock pushing up through here. We again have mudstone laid down, which again means that water was on the top. But the igneous rock has hit the top of the limestone and spread out at this point here. Last but not least, we have this rock here pushing through these different layers and coming through, and notice how it doesn't spread out until it hits the top here, which means all of these layers here were hard rock that held it together, and it could only just go through that tiny crack, and at this point where it hits the surface is where it's spread out. So this one here I would actually consider to be the youngest layer of all of this rock. Now when we put all that together, let's think first age and what happened when. The very first thing must have been this little guy here, because he hasn't disturbed anything else around him. If you can see evidence of disturbance, then that means something was there before. So no evidence of disturbance means he came first. Then came, look at this. We have two layers here that we have to figure out which came first. Think, which direction did it slip down? Did it slip down or up? If you line these guys up, you can see that these layers all line up, which means that this limestone here came first, followed by the shale, followed by the sandstone, followed by the limestone. Then we had erosion occurring where it all got worn down at the top there, and then this cross-cutting here happened, this fault where this part here slipped down into the crust and this one rose above it. So this was the original shape of the top of the surface at this point. Then we had sandstone deposited down again, and then limestone, because you can see the igneous rock here is pushed through the limestone. Then we've had this igneous rock pushing up and exiting up here underneath mud and spreading out. the mud has turned to shale, and then last but not least, this igneous rock has pushed through all of these layers to exit at the top of this surface area here. And that's the rock story. Now, it can be quite complex. You don't have to tell all the stories of all the rocks in your profile. You just have to give it a go and tell some of the stories. Now, also remember that there were other types of volcanoes that we investigated at the very beginning, like the Hawaiian Islands, and they were created by a hot spot. Now, there's actually evidence you can find to see if something's made by a hot spot or not. Remember, a hot spot is when a crust floats along the magma or the mantle below, and there's a particular place that's really, really hot, and it will push through the crust as it travels over it. And because that crust is traveling, say in this direction, as it travels over it, you're going to get successive points of magma breaking through and creating volcanoes. And you're also going to have evidence that the volcanoes on this end are going to be older than the volcanoes on that end. Now, a hot spot, when crust is traveling over it, because it's being pushed from all directions, it doesn't always travel in a straight line. It can often travel in a sort of line like this, as the crust is being pushed from side to side and up and down. And as you can see here, we've got this happening with the Hawaiian Islands. And you have evidence of underground volcanoes as well as the volcanoes that have actually come out through the surface, which are the Hawaiian Islands. So if you see evidence of a hotspot, that's what you need to look for in order to determine whether it's a hotspot or whether it's just a volcano made because of a fault in the crust. You may see evidence of magma being pushed out, and as it does so, it can be doing what we call this contact metamorphism, where it cooks essentially the rocks that it pushes out through and turns them into their metamorphic counterparts. So sandstone will become quartzite, limestone will become marble, mudstone will become slates. So you could see some evidence of this metamorphism where magma has pushed through the rock. Or if you see in your area lots of folds like this where it goes up or down, but no evidence of actual volcanic activity, you'll see again metamorphic rocks being formed because of the pressure that they're put under over time. So again, this can be sandstone will turn to quartzite, limestone will turn to marble, and mudstones will turn to slates. One other thing you will find is evidence when magma pushes up through the layers. You'll notice that the layers will actually push upwards as well. Just think of volcanoes as pimples on the Earth's crust. As this pushes up through it, the crust around it is actually pulled up with it as well, and so it tends to angle up because of the pressure of the magma pushing through the crust. So you don't have these layers staying horizontal. They actually start to push up because of the pressure coming from beneath. So I want you to go back now and have a look at your rocks and your Rock Stories project. You have to follow the following steps in order to try and figure out what happened. Number 1, do what I do. Identify all the layers, the type of rock they are, and their individual names. Number 2, add notes in about what must have happened to make that particular rock. So when I saw limestone, I immediately thought it's been covered by water. There's been lots of dissolved shells in that water. The water's evaporated and left the limestone behind. So that each one of those rocks tells a story. Add notes on each one of those layers about what might have happened to make it. Number 3, look for any evidence of folding or faulting, erosion, or intrusion. Okay? Number 4, number your layers in order of age according to the evidence that you've collected by doing these steps. And lastly, Put your story together and see if you can tell the story of what happened over time in that area to make those layers of rock.